Kinetic energy is the property that is associated with the motion of the object. We might say, in short, it is the energy by virtue of motion. Kinetic energy, there are various forms of energy, but kinetic and potential together, these form mechanical energy. It is by virtue of motion, means the motion has been created. From the rest, the body has been brought to the present state of motion. In doing this, some work has been done. That has appeared as kinetic energy of the body. Let's be precise. The work done in bringing the body from rest to the present state of motion, that's known as kinetic energy of the body. You know, third equation, v square u square plus 2as. Start from rest, u equal to 0. U is initial velocity. And multiplied by half m, you will find half mv square. Here you find half m2as. This is f into s. And just this product is equal to work, half mv square. This is the work done in bringing the body from rest to the present state of motion, that's velocity v. Means if the body is having the velocity v, it means the work has been done in bringing the motion equal to half mv square. This is termed as kinetic energy, half mv square. Mass can never be negative. And the square of anything, not only velocity, square of anything is always positive. So that way we can say that kinetic energy is always positive. If the body is not moving, it will have definitely the kinetic energy equal to 0. Body has the kinetic energy whenever it is in motion. This value also depends on the frame of reference you have chosen. For example, I am standing on the ground and some person is sitting in the bus. Bus is moving, it's having speed. For me, that person sitting in the bus is having kinetic energy. But for the passengers sitting in the bus itself, because they are in the bus and they are finding that person just beside them, they'll say he is not having any kinetic energy. So kinetic energy also depends on the frame of reference that is chosen for observing. Kinetic energy increases. That means the work done is positive. For example, when the body is coming down, work done is positive, speed is increasing, kinetic energy is increasing, work is done by gravity. If the body is going upward, gravity is doing negative work against the motion. So work done is negative, and in this case, the kinetic energy will decrease. Now we have to relate this important term kinetic energy with momentum. Kinetic energy and momentum, these two are to be related. This is half mv square. This is mv. If you square this and divide it by 2m, both become same. You just compare. Both are same. So you can say k equal to p square upon 2m. K is depending on momentum through square. This is a parabolic relation. So we might say that kinetic energy and momentum, they have a parabolic relation between them. Now one very important question, that's a very basic question. Which value is greater, kinetic energy or momentum? At the first glance, one might reply immediately either K or P. But see, anything is possible. Out of these three, all the possibilities are there. K might be greater, might be less, depending on the value of V. If you take V equal to 2, you will find P M into 2. You will find here half M V square, that is 2 into 2. See, I have put the value of K. I have put the value of P by taking velocity 2. So both the things are equal. That means K and P here are equal. Similarly, I leave it to you. You can do the practice at your home. If you put V greater than 2, you'll find K is greater than P. Similarly, if you consider V less than 2, you'll find K is less than P. That means K and P, certainty is not there. Which one is greater, you can't say confidently. It will depend always on the velocity. One more thing, this P, when you say K equal to P square upon 2M, we also mean P equal to root 2mk. In both the formats, the equations must be remembered by.